Alright, today we're going to talk about a fun topic. At least I think it's fun. And it's the triangular numbers. So triangular numbers are going to be the ones formed by, well, making triangles. So 1 plus 2 plus 3 and so forth and so on. So they're going to be able to form 1 plus 2 plus 3 all the way out to n. Alright, and so, well, there are different ways we can determine what that sum that we can call s, what that would be. And we're going to do one that is fun, in my opinion. And we're going to think about adding two s's. So I'm going to write s plus s is going to be 2s. And I'm going to write it in this form. 1 plus 2 plus all the way out to n. That's 1s. And then I'm going to add n plus n minus 1 plus all the way down to 1. So I just add them in opposite order. What would that look like? Well, that would give me n. Let's say there's n many of them here. And then I'm going to have plus 1 more. There's going to be n plus 1 blocks there. So I'm doing the n in red or pink and the 1 this way with orange. So now let's do 2. So you're going to have 2 blocks. And then you have n minus 1 of them. Put them in parentheses. But if you do n minus 1 plus 2, you're still going to have the n plus 1 blocks. So you are basically eliminating 1 block, but adding 1 block here. Eliminating 1. So whenever you do 3 here, you're going to do n minus 2. So you're going to have 3 blocks. And then you're going to have n minus 2 down here. So you're always going to be adding to n plus 1. And you're going to continue like that until you have n many. And you're going to be adding 1. By the way, that's 1. And this is n. So you're going to have n plus 1 blocks in every column. And you're going to have n columns because you're adding 1, 2, all the way to n. So each number you have n. So that's how we obtain that 2s is going to be equal to n times n plus 1, many blocks. So you divide by 2. And dividing by 2, the reason why it's triangular, because you're now going to have the lower triangle of this block. And then divided by 2, we get that s is going to be equal to n times n plus 1 over 2. So that's just fun. But there is another thing that we can think about. And that is the fact that if you think about this number, this is nothing but n choose 2. So in how many ways can I pick out of a set of n numbers? N plus 1. Sorry about that. In a set of n plus 1 numbers, how can I choose 2? So now you have a bag, let's say, or a box with, say, 5 objects. Let's say 5, n plus 1 objects, meaning, let's say we have n plus 1 balls, however many those are, and you're going to be picking 2 of them. So in how many ways can you pick 2? And that's going to be the same as this sum, 1 plus 2 plus 3 plus 4, all the way out to n. So let's try to analyze and understand how we can count this same number of ways we can pick 2 elements out of a set of n plus 1. How can we write it in this fashion? So let me erase a little bit so I can make myself some space here, and I'll be right back. Alright, so let's think about this. We have n plus 1 objects. I'm going to number them. 1, 2, all the way out to n, and n plus 1. I could have written the numbers and then drawn the boxes, but why make it easy, right? Anyway, those are my boxes, my objects, and I'm gonna tell you how we can write that n choose 2. So I'm gonna choose 2, and each number here in this sum is going to represent one situation. So the number 1 is going to correspond to the number of ways I can pick 2 objects whose difference, or the difference between the numerals that I gave them, equals n. Well, the only 2 options I have in that case are going to be 1 and n plus 1, because n plus 1 minus 1 equals n. That's it. Those are my only options, and that gives me 1. So I'm adding the first term. Now 2 is the number of ways in which I can pick 2 objects whose difference equals n minus 1. So what are my 2 options? Well, if I pick 1, the other one is got to be n. Let's use 2 different colors. If I pick this one, my other one has to be n, because then I do the difference, is going to be n minus 1. That's one of them. And the other one is when I do n plus 1 minus 2. Let me erase this one, and that's going to represent my other option, which is going to correspond to n plus 1 minus 2, which is also n minus 1. So that's going to give me my 2. You can imagine what's going to be the next one, 3. Numbers of ways in which I can pick 2 objects whose difference is going to be n minus 2. And my combinations are going to be 1 and n minus 1. So n minus 1 minus 1. Then you're going to have n minus 2 directly there. And then n plus 1 minus 3. So I get 3 different ways of doing it. And if you continue like that, the smallest difference you can get is going to be when you get the difference of 1, because you're going to choose 2 different objects. Let me erase, and I'm going to write that. So let's go up to n minus 1. Let's go there. N minus 1 is going to be in the number of ways that I can pick elements whose difference is 2. So the difference being equal to 2, if you grab 1, you can go to 3. 1, 3. Then you grab 2, you go to 4. Oops, I should have done 4 minus 2. Let's put it like this. And you're going to keep going on, and you're going to get all the way to n minus 1. And then n plus 1 minus n minus 1 is going to actually give you your difference of 2. So for each one, you're basically grabbing that one and going 2 after, grabbing that one, 2 after, and so forth and so on to make the difference of 2. Of course, you end all the way to n plus 1. And you can see how n is going to be, the difference is going to be 1. You go 1 to 2, 2 to 3, so forth and so on, all the way to n plus 1. So the differences are going to be 2 minus 1, 3 minus 2, all the way out to n plus 1 minus n. And you can count those. There's going to be n of them because you're going 1, 2, 3, all the way out to n. You can count them just looking at what you're subtracting. And so each one of these ways, you're counting in how many ways you can pick 2 elements that are separated by by n plus 1 blocks. Goodness, by n blocks, by n minus 1, by n minus 2, all the way down to n. So that covers all of the possible distances between the blocks that you're choosing. So when you add all of this, you're getting all the possible ways to choose 2 elements out of a set of n plus 1 elements, and that's also equal to 1 plus 2 plus all the way out to n. So that's another way of thinking about the sum of the numbers from 1 to n, which are our triangular numbers. I'm going to do one more thing, I think, and it's going to be the connection to the Pascal triangle. That's always fun to do. So let me go ahead and erase, and we'll talk about that.